So we are moving into the fourth BMP. This is BMP 4.5. That's the numbering system from the Eastern Washington, the Technical Guidance Manual. And those are also manuals that are available online for download as well. So the fourth BMP, which is trees, and Dustin mentioned a few things about trees, that trees really are our friends. And I don't know how many folks have heard of the Dr. Seuss book, The Lorax? Anybody? Yeah, a few folks, yes. It's one of my favorite books, and so for this part of our presentation, I speak for the trees. And that's what they said a lot in the Lorax. Trees are a really critical component. They can be also a workhorse for stormwater management as well. When you are adding trees or retaining trees on site, there are a lot of considerations, especially when you're putting in new trees, and really wanting to make sure that there's enough soil volume, that the soil volume is adequate and is really setting that tree up for success, because it's hard being a street tree. And the life of a street tree can be really tough when you're not allowing the roots soil volume that they need to be successful and to survive. So these are just the various components when you're adding trees as part of your design to consider. So there's a lot of great stuff that's happening both above ground as well as below ground in terms of trees. And so for above ground, trees are intercepting and they're storing precipitation. They're also promoting evapotranspiration, and they are slowly releasing the intercepted precipitation from both the foliage as well as the bark down into the soil. And so there's a lot of work that's happening above ground, and then equally in terms of stormwater management, and there's also a lot of work that's happening below ground with the roots. And so the roots play the role. They penetrate the soil. They also build soil structure, and they provide conduits for infiltration. And not all trees are created equal. So conifers, their root system basically acts like its own stormwater vault and its own stormwater management system. So conifers really are truly fantastic trees, but as Dustin mentioned, it really is right plant, right place. So conifers may not be practical for your site design, so it's really knowing the ins and outs of your site design and planning accordingly. So here it just says the flow control benefits, so transpiration, evaporation, increasing infiltration. The benefits truly do vary by tree. So is it a well-established tree? Is it a brand new tree? The type of tree, as I mentioned, conifers versus deciduous trees. They're the canopy size as well as overlap with the impervious area. So here, Dustin's going to jump in just a second as well, because this has to do with modeling. But this basically is showing that there are tree credits for retaining trees. You also get tree credits for newly planted trees, but you get more credits for retaining trees than you do for newly planted trees. And that's really a motivator for keeping trees on site. The goal for LID isn't to remove existing vegetation and then put in a lot of really fantastic bioretention facilities. It is to retain as much and protect as much native vegetation as possible while also adding bioretention facilities. And Dustin's going to jump in and explain this a little bit more and how it has to do with runoff modeling adjustments.
So generally what it is that when you're modeling for compliance with the Performance Standard 5 or 6, the Eastern Washington LID manual provides some guidance for credits for reducing the tributary impervious area to those facilities that you're sizing. And so the idea there is that for an existing or retained tree, you can actually map the canopy area. So you can get credit for 20% of the canopy area for an evergreen tree. It's not a whole lot of credit, but it's just giving some value to what that tree is actually doing in terms of runoff reduction. For a deciduous tree, then it's half of that benefit. And then for newly planted trees, because you can't map that, they give you 50 square feet per tree for an evergreen and 20 square foot per tree for a deciduous. So what you would be doing is basically quantifying how many trees you have that is near an impervious surface and reducing that impervious surface area that you put into those models for sizing based on those. So it gives you a little bit of credit in terms of being able to downsize those facilities. And oftentimes you're not going to have the trees dense enough that you're going to be able to completely get away from doing a downstream facility, but this gives you some credit.
So now we're moving into tree applications. So These really are, reducing the surface flow on streets, parking lots, sidewalks, and plazas. So it's reducing that surface flow from impervious areas. And large mature trees really do provide more stormwater reduction as well as other benefits than small trees. So it's that whole, not all trees are created equal. And that brings up getting the right folks in the room from the start of a project, and so that everybody is on the same page moving forward throughout the various phases of a project. And other things to consider, it's really important when you're including trees and siting for tree placement in a project, you really do want to think about available above ground growing space. So are there wires, are there other things like that that you want to consider as the tree matures, and below ground root space. So as the tree matures, making sure that there is enough soil volume for the tree to maintain a healthy and lifespan as well. So wanting to consider that. Also considering the type of soil as well as the availability of water, and then sight lines too. So vehicle and pedestrian sight lines are also really important considerations when you are planting and siting for new trees. And these are the limitations: adjusting adjacent structures and overhead utilities, because those can restrict tree growth, and really wanting to factor those in when siting for trees. If there isn't enough soil volume and you're locating a tree near impervious surfaces, then it really can limit the amount of soil moisture, it can limit the amount of nutrients as well as gas exchange, and doesn't set the tree up for success. And trees can be expensive things to replace, so really wanting to initially in the site design set those trees up for success. Other things that are really important to consider, especially in areas where there is a lot of snow, protecting trees when they're located near plowed snow storage areas. So especially if you are planting new trees and they're not that big in the winter, if it's in a snowplow area, then maintenance crews that are plowing that area may not see the tree at all, and that definitely impacts its lifespan if it gets run over by a snowplow. Whether you tie something onto that tree in the winter or you notify the folks that are plowing that area, just a factor in terms of setting that tree up for success. Other things to consider with placement of trees. So drying winds can really dehydrate plants that are growing in frozen soils. So that's another thing that you want to consider, and that's where that soil volume comes into play as well.